Life cycle of a star. I can describe stars at different life cycle stages. Starter, compare the hours of daylight at position X and Y. What season is each position experiencing? So, if this is the sun and earth, we can see that location X is located in the southern hemisphere, which is the part of the earth below the equator. This southern hemisphere is tilted towards the sun, so they would have longer hours of daylight. Position X is located in the northern hemisphere, and the northern hemisphere is tilted away from the sun, so we would have shorter hours of daylight here. The southern hemisphere, where X is located, is having summer, and in the northern hemisphere, where Y is located, they are having winter. Our galaxy is a spiral galaxy called the Milky Way. Our sun is here. Within galaxies are star-forming regions called a nebula, a star nursery. A nebula is a cloud of gas and dust held together by gravity. It's in these clouds of gas and dust that stars form. All stars begin in a nebula. A star is a large ball of gases that makes its own energy through nuclear fusion. Fusion is a process when hydrogen and helium fuse to form heavier elements. This process generates large quantities of energy in the form of heat and light. Stars undergo many changes through their evolution of life.
But way out there in space, there's huge clouds of dust and gas. And if one of those clouds of dust and gas is massive enough, its own gravity causes it to start to collapse. So it falls in on itself. And towards the center of that cloud, it gets denser and denser. It gets hotter and hotter. And eventually, the particles that the gas and the dust are made of are brought so close together that they start to stick together. They start to fuse. That's the energy source of a star. The star switches on and begins to shine.
Inside every newborn star, hydrogen atoms are fused together to make helium. This process is called fusion, and it creates the energy that powers every star. What happens to a star during the rest of its life depends on how massive it is at its birth.
A star like the Sun is in a delicate balance between gravity, which wants to make the star collapse in on itself, and the pressure that pushes outwards that comes from the energy that's been produced in these fusion reactions happening at its core. However, at some point in the future, the hydrogen runs out, and at that point, the core of the star will start to collapse in on itself under its own weight. It gets denser, it gets hotter, until a point where you can actually start to use the helium atoms themselves as the fuel for the fusion, pushing helium atoms together and making carbon and oxygen the next heavier elements in the periodic table.
As the star begins to fuse helium, it creates more energy, and that causes the outer layers of the star to expand. One day, our sun will grow so large it will swallow up the inner planets of the solar system, out as far as the Earth. It will become a red giant. For the sun, this will be the beginning of the end.
What happens is that the outer layers of the star get farther and farther from the middle. The force of gravity that they feel is getting weaker and weaker. And actually, the star loses hold of its outer atmosphere. Its outer atmosphere drifts off out into space. It expands out to become a planetary nebula. And they're some of the most beautiful objects in the universe.
Once the outer layers have drifted away, all that is left of the star is its core.
The white dwarf star is the dead remnant core of a star like the Sun at the end of its life. What's left behind is something that might weigh as much as half the mass of the Sun, but it's only about the size of the Earth. So it's an incredibly dense object. It's dead. There's no nuclear fusion going on anymore. It's incredibly hot, but then over millions of years it will gradually cool down to become a black dwarf.
Some stars, however, are much more massive than the Sun, and they lead very different lives. They are able to fuse heavier and heavier elements inside their core. The star gets bigger and bigger, Some grow up to 1,000 times the size of our Sun, until it has fused elements all the way up to iron.
And once we've formed an iron core, there's no more energy can be got from fusion. That core collapses. The rest of the star starts to collapse in after it, but then it bounces off. There's a huge shock wave, and in just a second, bang, the outer parts of the star are blasted off into space in a huge supernova explosion. These supernova explosions are so powerful that when one of these stars explodes, it can actually outshine the whole galaxy of which it's part, a galaxy of maybe 100,000 million stars.
For these supergiant stars, all that is left is the super-dense core, known as a neutron star, an object that can have a mass greater than our Sun but be less than 20 kilometers across. But for the most massive stars of all, we think when the core collapses, the gravity is so strong it becomes a black hole from which not even light can escape.
So stars are actually the places in the universe where the elements are created.
After the Big Bang, our universe contained only hydrogen and helium. All the other heavier elements were therefore fused inside stars.
The amazing thing is that virtually everything you see around you was made inside a star billions of years ago before the sun and the planets were formed. And when the star died and blasted its guts out into space, that formed the raw materials from which our sun, the planet Earth, and indeed ourselves were made. And actually, I think that ultimately that's one of the major reasons why I think understanding stars is crucial, because it's actually telling us where we came from.
Depending on the mass of the star, its lifetime may be millions to trillions of years. So all stars start in nebula, and either they can have the fate of our sun. So these are small to medium stars, and if the star is a larger star, this is the fate. As a star gets older, its energy decreases. The star eventually will no longer have enough hydrogen or helium to continue to radiate. Classification of stars. In the early 20th century, astronomers Henry Russell and Ejnar Hartsprung constructed a diagram comparing two properties of stars. This graph, called the Hartsprung-Russell diagram, HR diagram, became one of the astronomers' most important tools. And you can see stars are classified by their temperature, and temperature increases from right to left. So your temperature starts to get higher or hotter and hotter as you go from right to left. That's on your x-axis, and then on your y-axis you have luminosity or brightness. So we can see a very bright star would be a blue giant, and they would be hot as well. Where if we go over here, our red giants, our red supergiants, they would be cooler stars, but they would be bright because they're up at the top of the luminosity chart. Think of an HR diagram as a sort of family portrait of stars. It shows stars at different ages and stages of their evolution. The HR diagram is a tool to show the relationships and differences among stars. The HR diagram compares luminosity, the brightness. Again, it increases from bottom to top. So your very bright stars are up top and your dim stars are below. And surface temperature. And again, surface temperature is going to increase left to right. So you can see stars located over here are going to be very hot and very bright. Luminosity is the total amount of energy that the star radiates, brightness. The surface temperature of a star is determined by observing the star's color and the spectral patterns, spectroscopy. Astronomers classify stars into stellar groups based on their surface temperature. The groups are O, B, A, F, G, K, M. Group O stars are the blue, white, and hottest, while Group M stars are red and coolest. Our sun is the only one of many stars in the universe and is the closest star to Earth. Our sun is a medium sized main sequence star near the edge of our galaxy. So, what will happen to our sun? Okay, eventually, okay, here it is now, and eventually it's going to increase in size, become a red giant, explode into a planetary nebula, and then a white dwarf. But don't worry, that's going to happen in billions of years. At the end of the sun's life, it will gradually brighten as it's been doing for the last 4 billion years. The sun will expand into a red giant about 3 times larger than it is now. The increased brightness will boil the oceans and raise our temperatures to over 1,000 Kelvin. The sun will shrink and expand, charring the surface of the Earth with solar prominences. If Earth isn't destroyed, it will become a cold, dark chunk of rock circling a white dwarf. The hydrogen in the sun's core will run out. The last stage is called a black dwarf. Like all living things, stars have a life cycle. There are two possible pathways for a star's life cycle. You're going to complete this graphic organizer as your activity using the image on the next slide. So all stars start in a nebula, and if they are small to medium, they would go as the fate of our sun, or if they are larger than our sun, they will go into this direction. So you're going to use this chart here where stars start in a nebula. And again, they could either be a small to medium star and have this fate, or if they are a large star, they're going to follow this stage here. Analysis. Compare and contrast the life cycle of a main sequence, our sun, and the massive stars using the graphic organizer you created. Complete the sentence stem below. So we can say all stars begin in the same form, a nebula, that diverge depending on the size of the star. Average stars take the pathway of a main sequence star, our sun. More massive stars become red supergiants, then a supernova, and they could either turn to a neutron star or a black hole. So just continue writing, and you can explain either the main sequence, like our sun, or a larger star. For our exit, it's a star test question. It says, which student described these two celestial bodies correctly? So which student has the correct description of a nebula and a description of a star? So a nebula is a collection of dust and gases, that form star or results from dying stars, right? And then the description of a star is a sphere of matter with a density and temperature great enough to cause a nuclear reaction in its center. I hope you enjoyed learning the life cycle of a star.